This last section, we're going to do learning objectives A and B together. We're basically going to set up and solve story problems. If you like to have steps, you might find these helpful. So step one will be write a verbal model. And that just means read the paragraph and put it in your own words of what they're looking for. Step two would be assign some labels to that verbal model. And I don't technically require steps 1 and 2, but we'll think through it. The third thing is to write the algebraic model or the equation that you come up with. After you write the algebraic model, you're going to want to solve the algebraic model. After you solve it, check the question for reasonability. If your answer seems really far-fetched, you probably have a mistake somewhere. And then the last thing is reread what they actually want you to answer and then technically answer the question. Just because you solve the equation doesn't mean you necessarily answered the question they were looking for. So let's start by looking at this example. You're buying a computer system. The total system includes a CPU, a monitor, and a printer. The CPU, by the way, is the computer part. Okay. The total cost of the system is $1,300. If the CPU cost $895, the monitor was $225, what's the cost of the printer? Let X stand for the cost of the printer. Which of these equations best suits it? Now, if you look at equation B, for example, they're taking the total cost of the system plus the PCU plus the monitor, which doesn't make sense. They're double counting, so it can't be that. This one here, letter A, is saying $1,300, which is the total cost, plus something else equals the cost of just the CPU and the monitor, but not the computer. Well, that doesn't make sense. The last one is the only one that makes sense because it says the total cost, $1,300, really is the CPU, the monitor, and then the printer. This would be considered an algebraic model that we would come up with. Then we would solve it and answer our question. So let's go ahead and do that. To answer it, let's do 225 plus 895. When you do that, we're going to get x plus 1120 equals 1,300. To get x by itself, let's subtract this from both sides, and x will be 180. Now, gut test, does it make sense that a printer might cost $180? Sure, it seems reasonable. Now answer the question, what is the cost? So I would say that the cost is, this is money now, so let's do it more reasonable, $180. Now let's do this word problem. Chairlifts transport snowboarders and skiers to the tops of ski runs. The Iron Horse quad chairlift in Montana carries skiers at a distance of 3,250 feet. So I'm going to highlight that. The chairlift moves at a speed of 450 feet per minute. Find the time it takes to travel. So they want us to find time. Now remember those formulas I told you on the previous section to keep in mind. This is a very popular one and it's very useful. Take with you in life, distance equals rate times time. Okay? They've told us 2 of those 3 pieces. So all you have to do for this one is they told us distance, so I'm going to put 3250 here. Rate just means speed, so I'll put 450 there, and I'm going to keep the time as t for time. That is our algebraic model. Now all I need to do is solve the model by dividing by 450 on both sides because I have to get rid of the multiplication. This comes back as t equals 2.77. Now what do you label it as? Be careful, we're talking about feet per minute, so the time aspect is going to come back in minutes. Does it make sense that it would be a 7.2 minute ride if you're moving a pretty long distance? It seems reasonable, so we answer the question and it's going to take us 7.22 minutes to get to the top of the ski lift. Let's look at this problem. A low flow faucets help conserve water. They have a flow rate of at most 2.5 gallons per minute. So that's a rate, you guys. So my brain's even thinking about maybe distance equals rate times time. To test whether a faucet meets this standard, you time how long the faucet takes to fill 1 gallon of water. The result is 0.3 minute. Find the flow rate for the faucet. Is it a low flow faucet? So let's do this. They told us that the standard is 2.5, I'm going to do gallons per 1 minute. Okay. This one actually flows at, if we do it something similar, 1 gallon per 0.3 minutes. So really, we just set it up doing the gallons per minute because the requirement is how many gallons per minute they told us. So the setup is that they came up with the requirement is gallons over minutes. Fine. How do you check if your faucet's good? You look how long it takes to fill 1 gallon. You put the time down here, and I'm going to put minutes. So if I do in my calculator 1 divided by 0.3, you're going to get an answer of 3.33, let's write the label, gallons per minute. Now the requirement for this faucet, the flow rate is 2.5 gallons per minute. So we did the algebra and we got 3.33. Answer the question. Is this a low flow faucet? No. It's flowing way too fast. Over 3 gallons in 1 minute. It has to be under 3 gallons. It has to be at 2.5 minutes. The easiest thing to take away from this problem, by the way, folks, is what the word per means. Whenever you're doing math and you hear the word per, it means to divide. So that was the trigger here, is that's why I took 2.5 gallons, and then when I saw per, I knew it had to be division, and it's 1 minute that it's listed there. So that's the helpful hint I have. Okay, looking for a pattern. The table below gives the heights from the ground to the top of the first few stories of a building in Denver, Colorado. Determine the height from the ground to the top of the 9th story. Okay, so we're going to do this. I'm going to draw a picture actually. Here we have the lobby. And they're telling me the height from here to the lobby is 36 feet. Okay. Then they're going to have the second story is next. So this is story 2. And the height from here to here is 48.5. So if you just look at the picture, what's the difference? How much more did it actually grow in terms of the height? Well, it's 48.5 minus 36. That's going to be 12.5. So it looks like the second floor was an additional 12.5 feet. Well, what happens to the third floor? Well, the third floor is 61 feet. Okay, so if I imagine here's the third floor, the distance here is 61. Well, what's the difference between the third floor and the second floor? Well, 61 minus 48.5 is again 12.5. So do we see a pattern? Do you think from this floor to that floor and from this to this and this to this, are they adding 12.5 each time? Well, 61 plus 12.5 is 73.5. 73 plus 12.5 is this. So can we figure out the height from the 9th floor? Sure. Well, the 9th floor is going to be the lobby plus 8 more floors because the lobby counts as floor 1, right? This is my verbal model. Okay, I'm going to write an algebraic model. That's easy enough. The height of the lobby is 36. Plus, I'm going to have 8 more floors at 12.5 feet per floor. Okay, so in my calculator, I'm going to do 12.5 times 8, and I'm going to get 100. So each of all the 8 additional floors on top was another 100 feet. The lobby was 36. So is the total height from the 9th floor down 36 feet? It seems reasonable, so I'm going to answer the question and say it's 36 feet. I want you to think about which equation best suits this. You spend $75 on a 3-day trip. You spent $21 on day 1 and half of the remaining amount on the last 2 days. How much did you spend on each of the last 2 days? Let X represent the amount you spent on the last 2 days. So here's what my visual model is looking like for me. I see something like this. So I know I spent $21. I have 2 more days to pay for, and I have $75. The question is, how much did we spend on the last 2 days? So which equation of these three do you think best answers the question? Now you have to be careful with the wording of this question. Read it again. Let X represent the amount you spent on each of the last 2 days. So for me, these would be each of my last 2 days, is what X is. So how would you come about and figure out which equation it is? If you look at it, this is kind of my mental verbal model that I just turned into an algebraic model. So X is on each of the days, so that's day 1, and X is on day 2. So in terms of this, you'd add your like terms. So it's going to be 21 plus 2X equals 75. So based on that, equation A would be the right one to answer the question. Well, let's answer it to see if it makes logical sense. Okay, so I'm going to get X by itself, I'm going to subtract the 21 because it's adding. That's going to leave me with 2X equals 54. If you divide by 2 on both sides, you're going to be left with X is 27. Now, does it logically make sense that on each of the last 2 days I spent $27? Could it be that this was a 27 and that was a 27, a 21, and a 75? And it does make logical sense. Now for this problem, we have 2 different railroads. Our companies are building one rail line of a total of 1,780 miles. And here's what it says. Central Pacific Railroad averages 10.5 miles of track per month. By the way, you folks, that's a rate. Okay, so I'm thinking distance equals rate times time right now. Union Pacific averaged 23.6 miles of track per month. Again, a rate. The illustration shows the 2 companies meeting in Utah. As of the 1,780 miles of track were completed, where did the companies meet? How many miles of track did each company build? So if you think about it, this is total distance, right? And it's made up of the distance of Central and the distance of Union. So here's what I know. So I'm going to do distance of Central, distance of Union. So total distance I already know. So total is 1,780. It's made up the distance of Central Pacific plus the distance of Union Pacific. Now all I know about distance is the formula is rate times time. And I know their rates. So what I'm going to do is I'm going to say, all right, the distance of Central Pacific would be the same as rate times time. Well, what was the rate of Central Pacific? Well, it was 10.5 times time. Well, plus, now the distance of Union Pacific is their rate times time. What was their rate? Well, 23.6 times time. Okay. And I know that full distance was 1,780. If you bring these together and figure out combining like terms, 1,780 is going to equal 34.1 t. To get t by itself, divide by 34.1. This is going to give us an answer for time. When we get the complete answer for time, can we figure out how many miles of track they each built? Sure. Remember again, you guys, the distance for Central Pacific is their rate of 10.5. And then we're just going to take what we get for time and put it in there, and it'll tell us their distance. Like the same way, the distance of Union Pacific is going to be their rate of 23.6 times time from this equation. I'll put that in there, and that will tell us their complete distance.